The Monty Hall problem, a pretty famous philosophy thought experiment, is probably underspecified, at least in the most common tellings of it. But actually, I want to talk about a whole trio of thought experiments, so I'll go on to the Monty Hall problem, the Sleeping Beauty problem, and Newcomb's problem. Because although they're different, I think they all share similar issues. And in philosophy, basically everything comes down to how you specify the question. So really, that's the question and that's the issue. But I don't think that any of these problems are trivial, and anyone who says they are trivial probably doesn't understand them well enough. And I hear that a lot. I hear, if you isn't it obvious the answer to these questions? If anyone who thinks it's complicated is stupid. No. If you think that it's obvious, then you probably don't understand the problems well enough. So there is a lot of nuance here. Um, I'm not going to say anything close to everything interesting there is to be said about these problems. I'm just going to give my answers and leave it at that and try to keep it concise. But I don't know how long it will take. Um, Another disclaimer is that I don't think I'm going to say anything unique. I'm going to just say my thoughts, but it's very likely that my thoughts are also something that a philosopher has come up with a long time ago, and I'll look foolish for not doing the reading. So I want to say that up front is that, yeah, it's probably not going to be unique. So this is just one take on it. So let me start off with the Monty Hall problem, right? So I'm just going to read the Wikipedia description so that I can not be accused of making up my own description or not going with a conventional description. So the Wikipedia description of Monty Hall problem is: suppose you're on a game show and you're given the choice of three doors. Behind one door is a car, behind the other is goats. You pick a door, say number one, and the host, who knows what's behind the doors, opens another door, say number three, which has a goat. He then says to you, do you want to pick door number two? Is it to your advantage to switch your choice? So, okay, the conventional answer is that it's good to switch. That's the spoiler, is that it's good to switch. I'm not going to challenge that, really. I'm not going to say the conventional answer is wrong or anything like that. It is good to switch. But that's the question, is why is it good to switch? Because you would intuitively think it's 50-50, right? If it's 50-50 behind the two remaining doors, the host has revealed one of the three doors, so there's two left. Of those two left, isn't it just 50-50? And if it's not 50-50, if it's actually better to switch to one of the doors, how is that possible? How is it possible to have a 2/3 chance that it's better that you're gonna get the car if you switch? And there is an answer, but the problem here is, I think that usually when people give you the answer, they don't tell you the answer. They make up some other thing about statistics, and they rant on about, I don't know, Bayes' theorem and like complicated statistical reasons it's better to switch. But I think the real reason it's better is quite simple and surprises a lot of people when they find out, okay? So the real reason it's better to switch, and I like this explanation of it because in the Wikipedia description, it does include this detail, which if this detail is not included, then the problem is underspecified. But the detail is that the host knows what's behind each door. And so just to be clear, when the host reveals one of the doors to you, the host is not picking randomly, right? And a few problems would arise if it was the case that the host was picking randomly. For example, if he was like flipping a three-sided die, and if there was such a thing, if he's using random number generator to pick the door, then presumably it would be a possibility for the host to pick the door that you initially picked. And you pick the door number one, the host reveals door number one. Okay, well, that trivializes your choice, because if you know what's behind your initial choice, then obviously you know whether to switch or not, you know? So it's kind of implied by the fact that it trivializes the problem that that's not going to happen, but it's not usually stated explicitly that that's not going to happen. So that's excluded. The second thing that's excluded is if the host were picking randomly, then presumably he would be able to sometimes pick the door with the car behind it. But he's not allowed to do that. He's explicitly forbidden by the logic of the problem from picking the curtain with the with the car behind it. And the fact that the host knows which door has the car behind it means that in his choice he's embedding in some small way that information into the revelation. So when he reveals one of the doors and opens one of the doors, that choice itself is uh, using some of his knowledge that he knows which one has the car behind it, right? If the host did not know which curtain had the car behind it and he was just picking doors randomly, then his choice of door, then it would not be better to switch because he would have no way of embedding that information in his action. And so his action would tell you nothing. But that's one of these things is the most conventional tellings of the thought experiment are underspecified. Obviously, if it was possible for the host to reveal the door with the car behind it, it would make it obvious whether to choose that. You would just look, and if it has the car, then you would obviously choose that. So it's sort of implied. But how some people might interpret the problem is that actually it was random from the beginning, and what do you do if it just happens that the door that the host opens doesn't have the car? And if you interpret it that way, which I think many people do, then yeah, they're right that it's no better to switch. If it just happens that the door opened doesn't have the car. But actually, the host only has one door he's allowed to pick. He's not allowed to pick the door you picked. He's not allowed to pick the door with the car. So there's only one option left. And so he's really constrained in that way. So that's the only reason why it's better to switch, is because the host is revealing the information to you that he has. Okay? So that's the thing, is it's always a bit of a tricky thing where you think you're having a discussion about probability, but actually you're having a discussion about semantics and the specification of the problem. And depending on how the problem's defined, then you're going to get a different answer. Okay? That's the Monty Hall problem. So I'm going over that quickly. I'm not saying everything I would have to say about that. And yeah, maybe some people would still not understand my explanation, but hopefully that satisfies for now. The next problem I want to go over is the Sleeping Beauty problem. So again, I'm going to read the Wikipedia synopsis of the Sleeping Beauty problem to avoid accusations of bias here, okay? It says, some researchers are going to put you to sleep. During the 2 days that your sleep will last, they will briefly wake you up, either once or twice, depending on the toss of a fair coin, heads once, tails twice, after each waking. They will put you back to sleep with a drug that makes you forget that waking. When you are first awakened, to what degree ought you believe that the outcome of the coin toss is heads? So they have a little diagram that explains. So this also is a bit of a funny problem. It's getting into the field of anthropics, which is like, if in one universe something is more likely than in another universe, and that you have that thing happen, to what extent should you put your probability on you being in that universe? So it's like a weird field of probability, anthropics. But okay, the bit of the logic here, how I usually think about the problem is, I imagine that, just to make the math easier, you have two universes. You flip a coin to decide which universe it's going to be. So if it lands heads, let's just say, then you only get woken up once. Sleeping Beauty only gets woken up once. If it lands tails, then Sleeping Beauty, let's just say that you're Sleeping Beauty here, you get woken up 100 times. So just to make the math easier, let's say you get woken up 100 times, put back to sleep, fed amnesia, so that you don't remember any of the previous nights, right? Okay, here actually I'm going to go on a detour. So this may seem like a strange direction to go in, but I think it's helpful to go on this detour. So here's the problem. Okay, are you ready? Here's the problem. Someone comes up to you and offers you a deal. The person says, I'm going to offer you 6 bananas for $3, or you can choose another option. I'm going to offer you 10 bananas for $6. Okay? So that's the problem. What do you think? Think about it. Think about what's your reaction. Okay, I guess your initial reaction should be nothing because there's no question. As in, I mean that literally. There's literally no question. There was no question mark, right? There was no me asking you something. So that might seem kind of a fickle point, but in reality, that actually is a important point, I think, because in these kinds of probability problems, people have the tendency of just presenting the thought experiment, but then there's no question mark at the end. But if there's no question mark, there's no thing you're solving for. It's unclear what you're actually supposed to respond to. And it may seem like this is an obscure issue that only crops up sometimes, but actually, in these probability problems, I think there's the tendency for people to leave the question implied. So I want to point that out first of all. Okay. So let me amend the thought experiment to say what the question is. So just as a reminder, I think it was 6 bananas for $3 or 10 bananas for $6. And then the question is, which option should you pick? That's the question. Which option should you pick? All right, think about it. Think about it. Well, if you do the math, then the option that offers the more bananas is or best value for your money. That's 6 bananas for $3, right? If you just do the math, so you should pick that, right? Wrong. If you answered that, that's incorrect because it's unclear what you're trying to optimize for. Let's say these are exploding deals, like you have to pick one or the other. Then you might actually pick the one that's 10 bananas, even if it's a worse deal, or the math is, let's just say the math is worse. You might pick the one that's more bananas, even if it's less value for your dollar, just because you can't get bananas elsewhere and you're willing to pay more, so whatever. So you might accept it because that's what's on the table. So it's implied that you're trying to optimize for value for your dollar, but that might not be the case. And even we can take it further, right? Let's say that you place a negative value on bananas. So you're carrying a bag of bananas to the garbage, and then someone comes up to you and says, "Hey, I'll give you more bananas." You might say, "No, I don't want to pay you for bananas. I'm trying to get rid of bananas. If anything, I place a negative value on bananas." So it's even implied you're trying to optimize for getting more bananas, but that's not the case, okay? So that's kind of an obvious like retort, like clever, you didn't specify the value function. Um, but I think that's another thing is when you're talking about probability problems or like optimization problems or decision theory, yeah, you have to specify the value function, otherwise it doesn't work, right? Um, so I think that comes in here with the Sleeping Beauty problem. Oh, and you might actually object to my revision. You might say, "Oh, well, you're cheating by introducing the thing about the trash can. Like when you presented the problem, you never said anything about you carrying a bag of trash, but now you're introducing that late into the game. That's the cheating. Because of course, if you introduce other variables, then it changes it. But I don't think it is cheating because sure, like the problem never said anything about that you were bringing a bag of trash to the garbage, but it never said you weren't. So it's underspecified because you don't know what you're trying to optimize for. So it could be not. So you don't know. Um, and I think that's part of the problem here with the Sleeping Beauty problem is sure, like if you're trying to optimize for the number of times that you give the right answer, then you should guess that you have been woken up before, because in the world where you get woken up, gonna get woken up a greater number of times, and so that's gonna optimize for that. But in let's say you're trying to optimize for some obscure other thing, like you're trying to optimize for uh, the chance of ever being wrong. Uh, then it's like 50-50. So just to like drive home the point, let's make a revision to this thought experiment. Let's say that instead of flipping a coin, you flip a 100-sided die. And then in 51 of the 100 faces on the die, if you get anything 0 through 51, 1 through 51, then you're never going to get woken up. But if you come up with 51 through 100, then you're going to get woken up 100 times, okay? That's my first revision. And that is a true change to the problem. What is better in that case? Well, you're more likely to be in the world where you never get woken up. But if you do end up in the world where you get woken up, which is slightly less likely, but you're gonna get woken up way more. Let's say that someone gives you $1 every time you give the right answer, and someone takes away $1 every time that you give the wrong answer. If that's the case, then you're better off saying that you've been woken up before, because in the world where you never get woken up, okay, worst case, someone takes away $1, which isn't that much money. But if you're in the world, admittedly less likely, but in the world where you get woken up 100 times, then you care a lot more about giving the right answer in that case. Because if you say yes, then you get given $1 over and over again, and you end up with $100, or it might be $99, or it might 98. Anyway, you're gonna end up with a large positive sum. Whereas if you say no, then they're taking away dollars, so you're gonna end up with negative $98. So in that case, you're trying to optimize for giving the right answer as often as possible. So yeah, then you would say that you've been woken up. But let's make another change. Let's forget the thing about you get given $1 or someone takes away $1, or you can keep it, whatever. Let's say there's an executioner, and the executioner will kill you if you ever give the wrong answer. And it doesn't need to interrupt the flow of the problem. He can wait till the end and then check retrospectively if you ever gave the wrong answer once. And if you ever gave the wrong answer even once, then the executor will kill you. Okay, what do you do in that situation? Well, in that situation, you're better off saying that you've never woken up. Because remember, it's 100-sided dice, and 51 out of 100 cases, you're never going to get woken up. So if you're trying to optimize for being alive, which I think you are, then you're probably going to want to bank your bet on the 51 out of 100 chance, because that's slightly better, that's slightly more likely. So you really care about getting the answer right every time. And in the world where you get woken up 100 times, well, it doesn't matter how many times you say, yes, I've been woken up. You should, if someone asks you, do you think you've been woken up? You should guess, oh, I think I've never been woken up, because the stakes are so high, right? And it's slightly better. So that's the problem, is it depends on what you're trying to optimize for. And another way of saying this is the question is underspecified, because if someone specified the question and said, tell me if you've been woken up trying to optimize for this, or tell me if you've woken up trying to optimize for that, then you'll give different answers. Sometimes people will try to frame the question like, what is the probability that you've been woken up before? That sounds right, because probability has this air of like objectivity, but even probability, it's not like it comes in a vacuum. If you give a probability estimate, you're trying to guess something. And what is that thing you're trying to guess? Every probability estimate, it's a fraction, essentially. If you say something has 70% probability, what does that mean? It's 7 out of 10 times it's going to be true. Well, what is 7 out of 10? That's 7 divided by 10. There's a numerator and there's a denominator. The numerator is 7, the denominator is 10. So if someone asks you, what is your probability estimate for X? they need to, in that question, they need to tell you by what criteria are you trying to determine the numerator, by what criteria are you trying to determine the denominator. Otherwise, the question just doesn't make sense. Okay, a quick edit. I think that the actual problem statement is not, do you think you've been woken up before? It's, what is the credence you should place on the fact that the coin came up heads. But in the case where Sleeping Beauty, in the case where it's not a coin, it's like a 100-sided die, then I don't think that's a meaningful difference because the only edge case is at the very beginning. So everything that I said still goes and still stands. All right, so I want to move on to my third thought experiment, which is Newcomb's problem. And in keeping with the tradition here, I'm going to read the Wikipedia synopsis. Under definition, it says, at this time, in the standard version of Newcomb's problem, two boxes are designated A and B. The player is given a choice between taking only box B or taking boxes A and B. The player knows the following. Box A is transparent or open and always contains a visible $1,000. Box B is opaque or closed, and its content has already been set by a predictor. If the predictor has predicted that the player will take both boxes A and B, then box B contains nothing. If the predictor has predicted that the player will only take box B, then box B contains $1 million. The player does not know what the predictor predicted or what box B contains without making the choice. Okay, that's a lot of saying predictor, predicted, predict. I'm going to add another item here, which is sometimes people get fancy about this, like how accurate is the predictor. Just for the sake of this, I'm going to assume a near impossibility, which is that the predictor is a perfect predictor, that sometimes the predictor is called Newcomb. The Newcomb is like completely clairvoyant. He knows exactly what's going to happen, right? And he's just supernaturally perfect in that way. And that will make it a bit simpler. I guess there's a lot I could say about it. I have thought this is an interesting problem for a while, but I'm going to avoid indulging myself at this point because I don't want to go on a 5-minute rant where I have like a big build up and explain why it's so interesting. I'm just going to leave that to you. I'm just take for granted that you already find it interesting or you've thought about it to some extent, so that I can just jump right into my answer. And because one thing that annoys the hell out of me is people who say like, isn't it so easy? Isn't it obvious to pick or not pick? I think it's not obvious. But I'll get into my explanation in a second. But I think another thing about this is I think this is the most difficult thought experiment to talk about because I have to be most careful with my language. I have to try to be as articulate as I can. And even then, I'm not sure if I'm going to be able to articulate my position correctly, but I can give it a shot. Okay, what is the first problem? The first problem with Newcomb's problem is the fact that the problem statement is not well stated in the sense that there's no question. Remember back to the beginning where I said, what's a better deal for the bananas? Well, there actually has to be a question mark at the end, and it runs afoul of that problem. I just read the Wikipedia synopsis, and I'm rereading this. I gotta tell you, I don't see a single question mark at the end. And if there's no question mark at the end, then there's nothing I can respond to. It is a problem. It is what it is. What am I supposed to do about it? That's a separate thing. And it's not asking me what I'm supposed to do about it. And the reason why it's important to actually have a question with a question mark at the end is, again, like otherwise it's just unspecified. Because as soon as you have to ask a question, because we can invent a question that I'm supposed to answer. If we invent a question, the question would probably be something like, if you are picking which box to pick, then which box should you pick? That's probably something like that is the question, right? But that's highly problematic because that's introducing like a lot of ambiguities, like who is you? And I don't want to sound like, Jordan Peterson or something, but like, when are you being asked this? When are you being asked to decide this? Where are you? When are you? What do you know? Right? And this context comes in, and I think that muddies the waters. Um, I think this problem kind of breaks the mold of like a lot of traditional. It's like framed as a probability question or a game theory question, but I think it's not really. I think it's more uh, a challenge to the normal philosophical perspective, which is this sort of view from nowhere. So, View from Nowhere is the name of a book by Thomas Nagel, but I haven't read it. So, forgive me if I'm not using the term correctly. I don't know a better term. I want to say like the first versus second person problem or the platform insertion problem, like inventing a platform on which to insert the person to whom you're posing the question towards. I don't know a good term for that, so hopefully I'll invent it. But what do I mean by view from nowhere? Okay, instead of trying to come up with a term for it, what do I mean by that? I mean, when people usually think of how do they answer problems in for like philosophy thought experiments, I think what they implicitly have in mind is themselves in the scene in a certain kind of way, where think of like Who Wants to Be a Millionaire, right? On Who Wants to Be a Millionaire, there's different like things that you can do. You can do ask the audience. You can do if there are four answers, you can ask the host to reveal which two of the answers. It's kind of reminiscent of Monty Hall. But then there's another option, which is like phone a friend. I think they got rid of it because nowadays the friend can just like Google it, so it's kind of trivialized. But back in the day, they had phone a friend, and phone a friend is kind of what it sounds like. You get this question on Who Wants to Be a Millionaire. You call up. I know my friend John. He might know. And I ask John. And John, what is the capital of Sweden? Please tell me. Oh, it's Stockholm. Oh, thank you. Right. I think that when people think of themselves, I'm a philosopher. I need to answer this question. Where they picture themselves is as John. They picture themselves as the person in Phone a Friend. They're kind of impartial in the fact that they're not a participant in Who Wants to Be a Millionaire. They're not the one making the money. But also, they like the person who's competing on Who Wants to Be a Millionaire. They're trying to optimize for like that person having a good time and making his money. So they're good-willed. So they're like biased in your favor, but they're also impartial. So it's sort of an odd um, perspective on it. And what's like core about Newcomb's problem is that it makes this no longer work. It like isolates your thought, your decision in the thought experiment, um, to where your opinion on it and your uh, thoughts about the thought experiment itself explicitly influences the outcome. So, for example, if you're someone who believes that the best option, if you have a certain kind of opinion about the Newcomb's problem, then that's going to result in you making a lot more money. And human brains, they didn't evolve to necessarily find truth in all cases. They evolved to help you out, survival, gain more resources. So naturally, you're going to think whatever it is, the thing that gets you more resources, you're going to think that's a better option. And it sounds kind of condescending in that way, but it's sort of hard to avoid here. Like, for example, if there are different stages to where someone is progressing through the problem. Let's say I'm at the beginning stage and I have not had the problem explained to me yet. And then I have the problem explained to me. And that's another thing. When do I have the premise of the problem explained to me if I'm in the scenario? And then, okay, I have it explained to me, but let's say I haven't made my choice yet. Then I either make my choice or something becomes true that makes it such that in the future I will make a certain choice. And then once the preconditions for me choosing one box or the other are true, then that's the point at which Newcomb makes his prediction. And Newcomb predicts, I predict that you'll take one box or two boxes. And subsequent to Newcomb's prediction, there's nothing you can do to change your mind, essentially, because Newcomb is a perfect predictor. And so after Newcomb having made his prediction, subsequent to that timestamp, subsequent to that, the amount of money in the boxes is fixed, and absolutely nothing that you can do will possibly influence how much money is in the boxes, which is weird because your action itself is the thing that will influence how much money is in the boxes, but it really wasn't your action. It was the preconditions that will have led to your action. So really, let's say I was taking the view from nowhere and I was like on phone a friend and I was talking to my friend and I say, "Hey, where are you?" I'm stuck in Newcomb's problem, but I'm at just the beginning. I've had the premise of the problem explained to me, but I haven't made my decision yet, and Newcomb hasn't made my prediction yet. The box is in the other room, so I'm here. I'm gonna go to the other room with the box in a few minutes. But before I do, what should I do? Tell me, give me advice. How should I approach this situation? What do I advise to that friend in that situation? Well, I guess I would try to advise different strategies to force my friend to pre-commit to taking only one of the boxes. Uh, I would say, like, why don't you try to brainwash yourself into thinking that you can only take one box? And I would definitely not tell him any ideas I might have about why you should take two boxes. I would tell him, no, definitely this is solved. This is a solved philosophy problem. Everyone knows you need to take one box. I would tell him whatever I have to do to get him to do that action, regardless if it's true or not. I might tell him, why don't you hire an assassin to kill you if you take two boxes? And that outside factor is really going to incentivize you to only take one box. Or I'll say, I'll kill you if you take two boxes, so that's going to incentivize you to take one box. Or I'll say, why don't you try, how much time do you got? If you have enough time, then you should try to convert to a religion, the religion of two boxism or one boxism, that says that you have to only take one box, and then that will override your rational faculties because your religion is the most important thing. So like, there's all these strategies of trying to get the person to pre-commit. But what if the prediction has already been made? Then what kind of advice do I give? Well, what does that mean? Is it still a view from nowhere? Am I like a ghost who's swooping in at the last minute and like saying, "Hey, I'm gonna whisper in your ear. I'm gonna tell you you should actually take one box." Well, that doesn't work. The problem, I can't be some ethereal ghost that would allow something different to happen than what Newcomb predicted. That's not allowed by the thought experiment. The thought experiment says that Newcomb would have predicted everything that was going to happen. So me as a ghost swooping in and giving advice, that's not going to change anything from what it would have happened anyway. Or what if I am the person in the thought experiment? What do I do? What if I'm not giving advice? Well, it depends on where I am, right? Am I at the beginning? Am I at the end? And you might think it's easy. Like, you might think it's just say take one box. How complicated can that be? If you just do that, then you'll make $1 million. And I get that, but the problem is, like, there's not just that. When you're asking someone the question is posed like a proposition. Like, okay, you're in this place right here, right now, and what do you do at that point? But that's not how you experience it. How you experience it is you go through this whole sequence. You start out, you don't know, then you have it explained to you, then you make your decision, then Newcomb makes a prediction, then you go in the room, then you make your decision, then you get revealed to you. There's a whole sequence that you have to go through. And to pose it as like one proposition, unless the proposition is like, what do you do at the very beginning? Then if it is at the if the question is just asking you, what do you do at the very beginning, then even before you've made your decision or whatnot, then uh, that's a solved problem, I think. But if Newcomb has already placed the money in the box according to what you're going to do, if it's already set in stone, then I think it's a much more difficult thing, because it's not just one proposition, it's the proposition and everything that led up to that. Um so to to pose it as a question, like with a question mark at the end, is a little misleading, because to you it's not just that. And that sounds like I'm being evasive and I'm trying to reject the premise of the problem, or I'm just not engaging with it, or I'm refusing to like answer the question. But this problem of actually situating you somewhere as the person who to whom the question is being posed. Where are you? When are you? What do you know? That those kinds of contextual details change the result. So it can't quite be answered very well, given like the conventional framework for understanding the problem. And I would also say this problem is underspecified, because it's very difficult to pose the question correctly. But that's not by no fault of it's no, by no fault of the person who's trying to ask the question, but it's kind of inherent to the question that it is very difficult to specify such a thing that would allow someone to provide an answer. It's very. I criticize the Wikipedia article for not asking a question, but I'm not sure what question they would ask. It's inherent to the it's inherent to the problem, to the thought experiment, that the act of posing that question will lead to an answer, but it's almost impossible to do. It's almost impossible to ask a question that actually makes sense to ask. Hope that makes sense.